Hello tout le monde, j'espère que ça ira parce que j'ai fait la présentation en anglais. J'espère que ça va gêner personne.
Yes.
Donc, le titre de la présentation, c'est the title of the presentation is let's import a modern testing approach in Swift. I mean, I'm not talking about TDD or BDD or whatever discussions you could be seeing in social media these days. It's not about that. That's not what I mean with approach. It's basically, let's say, some months ago already, let's say I was doom scrolling the SIG forums, like a typical iOS developer does in the morning, right? And I found this. There was this post. Well, I didn't see it in September, I saw it afterwards, but you have this post, lots of comments like, okay, what's going on? And it seemed important because I could identify the name of the guy, Stuart Montgomery, that's an engineer of the test framework at Apple. And this guy says, okay, a new approach testing in Swift, and there's a huge like a message. There's around 100 comments on that thread. It was quite cool. It was quite cool because what they're proposing is that we are not like rewriting exit test in a way, but we are thinking about a totally different framework for testing. The difference is that we have exit test. It's a button tester framework. Works great since, I don't know, like 15 years, I would say. And let's say that the thing that was being a bit heavy on the, probably for Apple, aiming to evolve the library, is that exit test is based on Objective-C. So when we look forward, that latest features on Swift are macros. About 2 years back, you have Swift concurrency. Starts to be like a plugin road evolution of exit test. So they said, okay, September 2023, the last month we have been cooking an idea. So they did 3 things. They published the testing library. It's like built on the open, so it's super interesting. Second, they made a post on the Swift forums. And third, they also published the vision they have in order to build this framework. And well, I left the QR code there. I want to take a look at that later. It's quite interesting because you could see people like, of course, everyone like sharing their stories. Oh yeah, usually have like some problems testing like a certain edge cases or certain approaches. We couldn't deal with parameters, tests, etc. People, of course, like let's say that they're talking about, okay, now we have an in-house built solution to build, I don't know, with snapshots, etc. You have even people from Point Free. Of course, doing a bit like the advertising, okay, now for the composable architecture, we build these libraries, you have a Swift events, etc. So there's like a ton of knowledge there, so you want to check. It's quite interesting. Who am I? Because and why I'm talking about this. Today I work as an iOS developer consultant. I have been doing this since early 2013. It started as an internship on Android development. You have to use the Eclipse IDE and Android SDK. I don't know if you work with that, but it was not that great. Android Studio was in beta at the time. So luckily, that was for around 2 months. Then I had the opportunity to switch teams and work on the iOS team. At the time, I remember it was Xcode 4.6. I had to deal with an iPhone 4. And there were a lot of things going on. One, there was a thing called auto-eject. It was the new thing, and there wasn't much documentation that tutorials expected. So it was a bit hard to get the grasp of it. And well, let's say on my experiences, I have worked on several business domains, IoT, video banking, cloud for the companies, which those you can see at the bottom. So yeah, a decade of iOS development. Since then, mostly I could remember certain things that could be both disruptive or just a part of an evolution. And that's something I found interesting because, okay, I remember, okay, September 2013 was the release of iOS 7 with this whole new migration to a new design paradigm. It was the flat design. It was very annoying for us because we have to basically rebuild all the applications from scratch. But from there, you see, okay, Apple usually proposes new technologies, but at the same time, they still take care of whatever solution they have that basically deals with the same problematic. Okay, we have Swift, we already have JTC to solve the same problem, to build an application. Swift UI, we already have UI kit. To concurrency, we already have, I don't know, PBO operations, GCP, etc. So even if Apple proposing new solutions, you know that on parallel, the legacy systems or legacy frameworks, they are still taking care, and that's super cool because that allows you to, even if you feel like at the hype, like okay, you need to jump on this new technology, you are not necessarily forced to do it. I mean, you still write applications in Objective-C and UIKit, it will work. If we come back to the testing subject, I kind of followed the trace of the changes on the framework. Okay, exit test. We know that this button tested framework is the cornerstone testing framework for the whole Apple development ecosystem. And why 2015 is because the year after Swift being released. And you see that there are certain APIs that were released like each year that were aiming certain things that were missing with a mix between okay, better interoperability with Swift, sometimes better interoperability with the Swift concurrency system, and things that are mostly operational as performance of measuring, attaching metadata to our test. I think that's something that 2016. For example, if you wanted to do static testing, etc., you could attach and take the screenshot and attach it to your test report. So Apple, yeah, still takes care of the frameworks. Same for UIKit. Even in latest .PC, we got some outages. I don't remember which ones, but so okay, let's fast forward to September 2023, and they have this. As I said, they deploy this issue document, and they start saying, okay, we have a philosophy for this. There are 4 principles. They say because basically we have the freedom to do whatever we want. And they mention those, but let's say to be more concrete, they want a framework that is easy to, which code is easy to read, is easy to learn. So no matter if it is a less experienced developer or junior developer with no experience in testing, will just see your test and it will be super easy for them to understand, maybe to complete the test suite. How to plug, let's say the test results to a CI system. Today, there are ways that you could recover your, what's the name, XC test report, something like that. When you run your test, it generates, say, a file. Like normally you can map and scan, and you could transform an HTML, whatever. But kind of you can display the results of the test in a nice way. What they propose is like, okay, we are going to actually build an API so we can recover that in a more structured way. Maybe we could propose something nicer to do in this case. So the title was, let's import a model testing approach in Swift and how to do so. It's as easy as that, you could say. Normally, but that's not necessarily the case. So to import testing, that's the name of the model. I'm going to focus on those subjects, how to integrate it with your project. We have two macros introduced. We have test and suite. We have 2 freestanding macros, expected and required, and there's something called threads that's basically to customize the behavior of a test at the runtime. We're going to take a look at that. So, let's take it. So what about the integration? Basically a package. I created a simple package here. You can ignore the name. This is the latest known tag, 0.9.0. You need to specify the Swift version 5.10, otherwise it won't work. And then you need to import the framework on your test targets, but as a product. This is put on it's written on the documentation, so it's not something that I found really complex. But you need to execute this using a development toolchain. So I'm using the one from this Tuesday. And that's how you can directly import testing on your test targets. Sadly, the integration with Xcode and the SPM is not there yet. What's the reason? Because in fact, nothing, let's say, we could easily add this as a dependency of our, let's say, application targets. There's nothing like blocking that. In fact, that even allows you could have like a test written on your application targets. That's normally something that you would want. So probably there are still some things that they need to adjust on the integration side. Now, once you put the project, the dependency on your project, there's sadly also there's an API that we need to use to reach the exit test runner, so it can identify tests that are written with the new framework. This is called exit test scaffold. If you take a look, it's quite fun because it says apply providing temporary tools. So it's basically a bridge for integrating the testing library and the exit test framework. The thing is that what's fun because because at the beginning they declared the type on the documentation, but the type was at birth was deprecated, so it's quite fun. Hopefully that will disappear soon. And what's the reason of that? It's because for the new library, in fact there are a lot of changes, let's say, on the syntax. One of the reasons we need to do this is because exit test case is 100% Objective-C based, and because of that, if you take a look at the implementation of exit test case, in fact they use a type as NS invocation. What they do behind is that when you have a subclass of exit test case, so here you could have a number of methods, it's going to scan which functions have the prefix test. I think it's going to create an NS invocation object to each function. So it's like a variable. This is the target selector API. And that's how basically you can identify, okay, you have at built-in, you can know, okay, you have a number of tests. That's how it discovers tests, let's say, on your exit test case. And also it displays them on the test navigator you see at the left. As the new library is Swift-based, we don't have that. You're not forced to add the test prefix. And because of that, they still, I would say, they don't have a solution yet. They haven't offered a solution for test discovery. So we are obliged to use this for the moment. And the sad thing is that basically it grabs all of our tests written with the new testing library in a horrible just one exit test case that you can see here. So we cannot see the detail on the test navigator, only on the console. So let's go back to the key points. So this goes about the integration. So you have, two macros, those attach macros, test and suite. What does this do? It's basically, before, as you said, we added the test prefix to the name of our functions. We're forced to do that for test discovery. how the new testing library discovers functions that are meant to be testable is because of the annotating the function with the macro. So you have test, because now we have flexibility, because we are not attached to the legacy XCTest case API. So basically, you could turn any function as a test function. So you could have a global function notated as test, all good. And at the same time, it offers the flexibility that if you have, let's say, a set of tests in a context, you could apply the suite macro, and you will basically follow kind of the same idea that you had before with the XCTest if you have a set of tests inside a context. One of the cool things about the suite macro is that you are meant to apply it to certain types. Could be a struct, a final class needs to be final, or an actor, but that means that you have control over the initializer. What's the cool thing about that is that you can, in fact, initialize your dependencies in the initializer. You no longer need to use the setup functions or even to understand the lifecycle of the setup and tear down functions. There are many. There are instance methods of setup that are static versions of it. It's a lot to understand when you just want to configure a dependency. Probably a macro. So I would say, besides the byte to the test prefix, byte to having your dependency as defined as a class property, you could define it as an explicit and grab optional, or having it as an optional. But now you are going to win the determinism, I would say, that you are creating the dependency on the initializer, so you know that the value is there, no longer, you don't need that anymore. And there's another, I would say, good thing that comes with both test and suite is that now we have an API to run parameterized tests. What does that mean? I want to show you. Here you have a simple, say, implementation of how to solve the FIS bus lead code problem. And here I have it's something that as far as I know, doesn't have really a way to solve it, because what I want to do is, okay, I want to test my algorithm, could be FIS bus, could be something else more complex. But the thing is that, okay, I want to test, in fact, the same algorithm, but I want to test it by providing a set of test data. It could be just a small array, it could be a large array of thousands of values. But the thing is that what's the correct way to write that using XCTest? Because unless you know a better way to do so. But what I knew is that basically you need to for loop over the whatever collection of test data you have and execute whatever code you want to test, and then check the expectations, do the match. But for each element that you have in your test data, and so all the iterations, in fact, are lost because for XCTest, you are just running one test. So what happens if you have, I don't know, like 10,000 iterations and there's a particular one, 3 ones that fail? How could you recover that information? How you could do actionable stuff? How you could, for example, if you like TDD and you do some modifications to your code and you would like to rerun, maybe use the fading test. There isn't a simpler way to do that using XCTest. One trick that I knew is using this API, the XCTest context run activity. That, for example, if you want to log something for each iteration, I think it was this one, I believe. You would get something like this. You could, for example, you get the log for each iteration. You could see, for example, the one that failed, but it remains being just one unit test. So it works, but it's not that great. Today, what the testing library proposes is you get your function, you can see that I have no need to put the test prefix. Very simple. You just whatever I need to execute to test, I retrieve the result, and then I assert if that matches or not. But you can see that, okay, you have the test macro here, and it is flexible enough that I can provide my test data into the macro itself. Of course, here is a bit ugly. Imagine, for example, if you were recovering this information from a file or something else, because this is compiler. Sorry, it's computed at build time, so you could inject a function or something else. It's cleaner. And what you have to do, well, on the function is, okay, you have these arguments, is a collection. So it says, okay, it's a collection. You have these arguments, it needs to be a collection, it's well, generic over the type of the collection. And that's it. And then on your function, you need to put on the signature that, okay, I'm expecting an argument that refers to each element of your collection. In this case, this is an array of tuples, so that's why I look like this. Basically, the input value that I'm going to feed the FizzPass algorithm, and then is the expected output is typed as an array of strings. There's two other, let's say, possibilities that you have with the arguments. Is that, okay, you could pass one collection, and you can also pass two, and there are two ways to do it. One, you could pass two collections as separate units, or you could use zip. What's the difference? Here, I know that I want to iterate, or make an iteration for as many items or elements I have on my collection. So for each iteration, I'm going to receive, as you may already know, first iteration, I recover the first element here, the first element here, then the second element. So also I know how many times this is going to run. How many will be when, I think. There's another way to do this. Of course, FizzPass is not the correct problem to solve with this, but if you're not using zip, you could, as I said, you could inject two different collections. But this works different. This basically does a factorization that for the first item that you recover from the first collection, it's going to make as much iterations as it can find on the second collection. Then you can imagine it's like a nested for, so you have a complexity in 2 times, I think it's worked. So, well, that's the thing about parameterized tests. These are very simple to write now. And they mentioned that the parallelization, it works by default, but on the vision document, and also in the documentation, they talk about that it should be optional if you don't want to have parallelization. But at the moment, I didn't saw a way to turn it off in the documentation. It's something that they are also working on, but it's not explicit. Let's go back to. We talk about the test macro and the arguments that you can pass to deal with parameterized test. I think that you saw that when we were asserting the value, we no longer were using the xctassert API, but now we use, it's another macro, it's a freestanding macro, it's called expect. I think that this goes back a while, because while you could write all your asserts as xctassert and kind of like ignore the semantics of the other variants that you have, it's kind of like this kind of like recovers that way of thinking. You just have a expect everywhere, and it's up to you to kind of like to set some logic inside and to kind of like to understand the semantic fit based on the operators. This is also provided by the testing library. Cool thing is that basically all the type of assertions that we have today are mapped, so it's kind of like quite easy to get a grip of it. And then there's the 4 key point that I wanted to show you is test threads. What are test threads? Are basically conditions that you can apply to a test that are going to be consumed at build time, and can be applied to both a test that works in isolation as could be a global function, or also to a suite. So you have this enclosing type that wrap several testing functions. Let's say the capabilities that is for the moment is you could, similar to what we have on exit test, is the exit test skip API, something that was released a couple of years ago, I believe, that you could kind of in a more official way, kind of to disable test, not by just kind of putting an underscore before the test prefix, but by correctly using the API. On the macro, there's also like a sort of flag that you can use to enable or disable the test. The cool thing is that it's not like just like a Boolean property that you flip off. Is you can really tell the test runner, okay, this test is going to run if, and then you can provide a computation that you can do at build time. So imagine, for example, if you are manipulating like a feature flags or something, it's kind of it's quite nice. For example, if you have like a different like environments and different environments, maybe like a deal with different tests, etc., could be useful. There's another one that says time limits. That one I found it a bit weird for the moment. Basically, it kind of like remembers the usage of the wait for expectations API. That maybe you do some asynchronous work or very heavy work, and usually you set like some seconds there, depending on the amount of work to do. The weird thing is that the documentation says that it works by it's measured by minutes. It's a unit, not seconds. It's super weird. Just by default, all the tests have a timeout of 1 minute, but that it's not possible for the moment to set a smaller timeout than that. So that's kind of weird. I mean, for the moment, why would you need to put a timeout of 2 minutes? It's interesting the use case, but it is what it is. And if you apply one of these threads either to a suite or to a parameterized test, you're going to gain inheritance. That means that maybe it's easier if I show you. For example, here I have a parameterized test, right? Let's say this is going to be enabled if, well, something happens. And I told you that maybe you could put that in an isolated computation. That is computation, and this is going to be returned Boolean. And well, let's say that's going to compute something at build time, and you could feed that to the macro. And the thing is that this is going to modify the execution of all the iterations of the parameterized test. The thing is going to be applied to the time limit. There's also let's say like an analog API that is to not enable but to disable. So the same idea, but the semantics are different. So, and I think I forgot to show you something, is that you could, for example, have an enclosing type. This one is going to be a suite, and then you could have like a case A, like some stuff that you want to test. And here you could also apply the same idea normally. Sorry, I forgot. By doing so, the same thread, the same characteristic or condition, built-in condition, is going to be applied to execution to all the tests inside the enclosing type. Let's go back to the presentation. So we talk about the threats that can change the behavior of the test at build time. There are a set of those that, in fact, are mostly to manage information that you provide to the test and that you want to recover, specifically when the test fails. There's 4 types that the testing library provides. We have one is comment. Luckily, the comment one, in fact, is a type that confronts with expressible by a string literal API. That means that you could just provide a string and it's going to be treated as a comment. You can imagine it as, for example, if you were using a XCT assert equal, for example, assertion, you are like matching to values, and then there's a third argument. There you could provide a string that's going to be outputted on the test report if the test fails. It's basically the same idea. There are tags. Tags, the documentation says that there isn't really an impact on the runtime, anything. Well, the library doesn't care if you apply those. The usage of the tags is basically that you could have filtering. And there, the cool thing is that, in fact, tags are, let's say, strongly typed. One way to define them, in fact, tag is a type, and you have to stand. Then you need to create a static bar. Here you could write something. This is my tag, and should be this is static, so there, and then you apply also the tag macro. So a lot of tags everywhere. And the cool thing about this is that there's also here an API where you could add tags to your tests. And imagine that this could be defined on some sort of like a package that you could share between different test targets. The cool thing is that, imagine, well, it depends on the architecture of your project, but if you have like some sort of like a feature-based modularization, maybe on the test targets, you could profit from a common definition of this. And then when you run tests, you could filter tests that runs on different targets, but maybe that follows a same semantic, maybe that deals with a same API that are layered somehow on the same level of the hierarchy up to discussion, up to discovery. But it's like a nice addition because today we don't have that exit test. And last, and this I found it quite fun because there's a bug on the type system. The usage of it is basically that you could write a unit test, and this structure provides some properties, an ID, a title, and URL. The idea is that, okay, you write your test, but it's kind of like in the sense that, okay, you receive a bug report, so probably you need to link it somehow to your Jira ticket or Crashlytics or something, and it's that on the same code that you could provide these values, kind of like the ID of the bug on your bug report system. I don't know. Also, you could add the link of your Jira ticket somehow. So it's like you add a test, and also it's well documented in a structured way. So yes, there's a bug on the type system now, and if you don't believe me, there it is. There's a structure called bug, and those are the properties. How to deal with those? For example, let's say, okay, I wrote this function. In fact, I'm going to write it now, just for fun. So here is like a fix, like a checks fix, let's say. We add the test macro. And here, I think it was a singular bug. First, you need to put in the URL, then you need to provide an ID, let's say this Andre, and then you can provide the title. So that's information you can recover from there. Yeah. Back the ID and a title. So there's information that you should match or whatever backtracking system you're using. There's a type that's called the issue also, but it's meant to be used internally, so there shouldn't be let's say the need for us to deal with it. And it's basically that when you run your tests, okay, you get your test report, but all the failing tests, in fact, the way to structure them, the library internally is going to manage the issue type and not the bug type. So I think that's part of the, let's say, like a plugging the new API modeling that they're proposing to CI systems is something that they haven't built. I don't know if it's built yet or announced yet. If you take a look at the source code library, it's basically API modeling. So that's what they propose. Looks nice, but we'll see how that ends up working. Let's go to the presentation. So wrapping up, we talk about the integration. You can see it's quite simple, but it still needs to be bridged using XCTest, using that type that's already deprecated. And if we compare with with all the evolution that the XCTest API has had over the last years, we are not there yet. So we're missing performance measurement. We are missing UI tests. About that, I saw a comment of Daniel Steinberg, I think, well, 2 weeks ago. I wrote my comment and he said maybe that's stuff that they wouldn't build in public. So that made me think, I didn't talk about that. Maybe we'll get some good news next week. Maybe there's also a Swift testing, I know, the UI framework being built, but not in the open. So that's it. Hopefully you get some information about what Apple has been cooking. I told you that the first announcement was in September. They have been, the development in the library is quite active. In fact, I checked the repository on Tuesday. I could see commits happening almost every day. So even if you want to participate and contribute to the project, I don't think they will say no. So that's it. Thank you. Oh, sorry, if you... oui, si vous avez des questions, oui.
Est-ce qu'on peut donner un nom au test paramétré pour quand ça échoue, on est dans le rapport test machin avec un rem, parce que là dans les données tests, tu avais 1, 2, 2 machin. Est-ce qu'on peut leur donner un nom significatif qui permet vraiment d'identifier le cas
Tu parles de XCTest ou
Non, dans Swift testing. Parce que en fait, chaque paramètre du test paramétré correspond à un cas.
Ah oui, en fait, je sais pas
comment dire, mais donner un nom qui a du sens. Alors, en fait, si on teste un cas particulier, si on teste un edge case, ça marque le edge case machin à rater.
En fait, oui, dans le test navigator, en fait, tu vois rien. Parce que on voit seulement les tests qui sont définis comme un XCTest case. Mais là, si tu exécutes les tests, en fait, les tests qui sont comme tests paramétrisés, paramétrés, chaque itération, en fait, normalement, le bon nommage, c'est each test case, c'est comme chaque invocation. On le voit comme ça. Donc là, tu vois, on dirait comme le nom du test. Et après, tu vois comme chaque itération, tu peux voir
oui, tu mets un nom en pif. Comme ça l'affiche tout seul. Ok. Oh, ça rend bien. C'est plus beau que les tests. C'est la poussière. Ok, merci.
Je pense qu'il y avait même, si tu fais un test qui échoue. Attends,
un gros emoji rouge.
Donc il y a plein de trucs. Si tu fais un... Donc là, envoyer un test. Et ce que je vais faire, c'est que ça va échouer. Et tout ce que tu pouvais jeter un commentaire. Et je pense que ça, on verra ça dans les logs.
La proteste, il voit le commentaire?
Oui, pas le test, mais tu verras si ça fail, tu verras les commentaires dans les logs. Et normalement, c'est un feature not a bug. C'est marrant.
Pour moi, les infos sont attachées au truc. Voilà, tu vois pas du tout ce qu'il y a dessus.
Les commentaires, je vais avoir 2 mots, je pense.
Je sais pas si c'est la logué.
Il faut peut-être mettre le commentaire sous le test. Sous le test, pour que dans la syntaxe, ce soit donc sous le.
Ah, voilà. Elle est là.
Waouh!
Waouh, là c'est la magie.
Mince.
C'était magique. Là c'est la magie.
Oui, j'étais sûr. Non.
Bah, du coup, ouais,
C'est carrément bien.
Attends, si tu cliques dessus, là, le truc sur les lignes, c'est parce que ça t'amène en code.
Tu l'as?
Si tu cliques sur la partie en fluo, ça t'amène dans le code à l'endroit où ça arrive, c'est ça?
Oui.
Ah,
Après, normalement, si c'était en paramétrisé, on peut essayer un truc. On va récupérer ça. Ça, on commente. On le met là. Et ici, imaginons que c'est là. Donc là, on a le test paramétré, mais qui va échouer dans la deuxième itération de moment. Soit, oui, tu as la result, oui, parce que j'ai mis en extra le monde. Mais par contre, je ne sais pas si c'est affiché. Ah non, il n'est pas
peut-être que
affiché.
si tu le mets
Non.
dans ta liste, au-dessus du premier item, au-dessus du deuxième item, genre si tu mets ligne 44, enfin, là où ça échoue, tu peux tester.
Comment ça, tu?
Ouais, c'est ça. Peut-être que là, ça donne un nom au cas.
On peut essayer. Ouais. Non, apparemment, oui, non. Ou peut-être que je ne sais pas comment le faire. Mais bon, c'était les features not a bug. Je ne sais pas s'il y a d'autres questions ou commentaires. Complaints?
Merci beaucoup.
Merci.